I'm sure most of you are here to find out how I used Blender's GeoNodes to impersonate the unique limitations of the Commodore 64's graphics. So instead, I'm going to talk about how I made the music. Feel free to download the blend file and use the node groups in your own projects. After watching most of What We Do in the Shadows, I figured out that the theme tune had a time signature of 10/8 split into 3/3/2/2. So that's 1 2 3 1 2 3 1 2 1 2 1 2 3 1 2 3 1 2 1 2. I don't have the same skill at hearing melody as I do at hearing time signatures, so instead I looked up a bit of sheet music that, well, actually this one isn't in 10/8. So I assumed that the person who wrote it is good at hearing melody but not good at hearing time signatures and is my inverse, otherwise I've just got the tune wrong, haven't I? The C64 has exactly one good synth sound, so as long as you want your music to sound like 3 bees buzzing in harmony, you're onto a winner. You could of course make it sound like this, and then you could also use the Here Comes the Sun by the Beatles guitar line as a background. At one point I was going to make, like, not actually Commodore game, but a very close impersonation thereof. I produced a whole lot of pixel art that I didn't really use. But after a while I decided that it would be better to do some kind of intro sequence based on the series of paintings shown in the intro to the show. So I used this website to convert this image into this, which, well, it's a C64 loading screen using a bitmap mode, which means that while it uses the full 16 colours, each character, which in this case is a 4x8 pixel block, only uses 4 of them. It's very accurate, and you can convert it to a file format that the C64 can use. And then I decided I wanted this version of it. And now we can finally get into Blender, and the first thing we see is the text appearing. Were this a Commodore, this would be a custom font. Probably the lowercase would be the top half of the letter and the capitals the bottom half, and we were able to colour them. But of course in Blender there's a whole collection called letters, and they're all named shadow font dot whatever letter it is, with this, I believe this character is called Pipe, being at the end. Let's have a look at those, and we can see there they all are laid out like this, with Pipe is actually a animated bat. We'll start by showing how the bat is animated. Let's go to bat here. We can see we have a pung with each of these, the 8 characters of the bat animation sitting on top of each other, and a collection of material nodes, meaning that you can have multiple bats on screen at once. Interestingly enough, this is all actually running at 50 frames a second for that authentic C64 animation look, which means I'm doing frame by frame animation at 50 frames a second, even if there are only 8 frames that are looped. So how is this text appearing like that with the bat forming a kind of cursor? Well, if we jump into geometry nodes and select it, we can see a whole load of nodes here. We are able to set a string, frame start, frame end, and frames per letter, so how many frames it takes for each letter to be drawn, and the cursor character, in this case the pipe, which we know is in fact the animated bat. The bat appears elsewhere in it. We will get into that later. And if we look inside here, this object text, we're string as an input, and plus we have the letter collection being letters, and the letters used being the string showing the alphabet, and then at the end pipe. Interesting, this is kind of important. If you type pipe, it will appear after the alphabet in alphabetical order. Objects will appear within a collection in alphabetical order, so pipe will be at the end, which is why pipe is in the end at this strip. And if I go into here, short explanation, this basically draws a grid with each of the letters of this string here, the string that is written, along the X and the A to Z, and then finally pipe along the Y, and it compares these. It compares the X and the Y, and when it finds that they match, then it will instance a collection of on that grid, and then it will shuffle it down so that they all actually appear horizontally. And interestingly enough, you'll notice there are two red lines here, which should mean that the nodes are not working. That's a red warning of not working with a little invalid link exclamation mark there. However, if I actually disconnect either of these, it basically breaks it. If somebody would like to explain that to me, they would be more than welcome. So let's go out of this here and we'll explain how it is actually drawing the letters. And that's what this is doing, which is possibly, there's a more elegant way of doing it than this, but we basically got one collection writing the text, one collection adding the cursor at the end of the text, and one collection erasing the text, and you're able to set the frame it starts on, the frame it ends on, how many frames it takes to draw each letter, and what the cursor character is within this. So this would be easily customizable, so you could create your own font and write your own letters with it. And they don't have to be pixel art. You could have actual individual objects for this text. At the moment though, it is fixed width. Every letter is exactly one Blender unit long, and there isn't functionality within this to change that. And now we finally get onto the drawing of this. This is entirely animated on the phone, starting at the end and deleting a little bit each time, so that we can basically have an animation of the word shadows drawing, not done in Blender at all. Oh, we do have Sprite Sheeter, where you can if you've got an image which is a sprite sheet, you can use this group and set how many frames are on the X and Y. And frames per frame is a bit confusing, but especially as this is at 50 frames a second. So if your animation is running, if your sprite animation is running at a more sensible, I don't know, 25 frames a second, or even 12.5 frames a second, which is completely reasonable, we could go down further than that. You might want to set frames per frame to 2, so it takes 2 frames for each of these frames to be drawn, etc. Note that that goes into the vector of your image. We can then go into this blue ripple, which is it's not very complicated, but it's creating that blue ripple at the end. But you may also notice that this multiply here is keyframed. That is because after a certain amount, all these things that are rippling, like this text, I don't want it rippling, and I don't want to have to create an entire new material and a whole different collection to have a second version that isn't rippling. So basically, after a certain while, the rippling is mixed out. So on we go. What's the next thing that happens? Boom! As you can tell, the background color is keyframed, and it creates a load of bats. So we see that on this one, we do actually have geometry nodes on this object, though it's not animating the text. What it is animating is the bats into which it explodes. So let's go back to the geometry nodes. My first ever use of simulation nodes, what we basically have is a load of bats, which are all an object bat, a second object called black bat, using the same animation sprites as before, animated in the same way. Everything is locked to this grid. At a certain point, when bat is clicked, note that that is keyframed, every vertex of the model will turn into one of these little bats, and every frame, it will be randomly, its position will be randomly moved about. We pick a number between 0 and 1.8. If it's lower than 0.8, then it is moved in a random direction, up, down, left or right. If it's greater than that, it's random direction. It's the direction in which it's moved is set by this figure here. So it starts off going up, with the bats going up into the sky, and then at a certain point it goes to 0, they just stay still, and then after a while it goes down. And then we have this image scrolling up the screen. That's just, animated, an image scrolling up. And at this point, at around this point, the Commodore would swap between high-res mode and multicoloured mode, which means that, well, actually at this point you may notice that everything else is high-res, but after a while we'll see that some characters use up to 4 colours and have wide pixels. But before that, I'm going to pause and drink a sip of tea, which will probably be edited out of the video, but we will see. Let's explore the material and geometry nodes that make this possible. We basically have two objects that I can move around the screen, and it locks to the grid, and the face is between the two of them. Two objects are basically the same, and they use the same geometry nodes. What we notice, image plane is not ticked in there, and material hasn't got anything in. The bottom left one has got image plane ticked and material set to pick. So what this does is send frame size to material. This picture frame size, and we see that the picture frame, depending on how wide it is, it will select one of these sprites of the sprite sheet. So if I make it longer, we'll start at it just being like that and go on. As you see, it's going through a whole series of these, and when it goes above the 9th one, it kind of breaks because it will loop. It loops back again. Where was I? So that is done by seeing how far apart the objects are and sending a what are they called? One of those variables that you can send between things, but I can't remember what they're called right now. Attribute, that's what they're called. So the image plane, it basically sends the store named attribute that then will be picked up in the material nodes, and then the material blah 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 blah. Yeah, it will send an attribute to material nodes, and then material nodes will pick it up, and then we'll be able to pick up the material nodes, and that's the wrong material. Picture frame X will be able to pick up the attribute there and use it to decide which frame of this sprite sheet it wants to use. So that's happening independently of the X one and the Y one. Meanwhile, inside there is an image. Now this is, swap that back to geometry nodes, and that is basically just drawing an image plane. That is quite simple. What is going on there is happening in the shader again. So here we have this. Let's move that up a bit. And what image are we showing? This image here. Now, strangely enough, let's go back to this pick, which is where it's going. We actually got two of these with different texture coordinates, controlled by objects called pickspace1 and pickspace2. Here they are, pickspace1 and pickspace2. If I move them, that one's not doing anything. If I move this one, I will actually be moving the image around. Now these don't actually have a grid lock built into them in geometry nodes. So these always move in. Let's have a look at a graph editor here. And we'll be able to see that every movement of these, it just basically jumps from one position to another. But you also notice that it kind of fades between one picture and the next. So I move one while what you're viewing is the second image. And to look at that, let's go back to the shader editor. What is going on here? So yes, we have a mix node. Got a Bayer matrix image to control how it fades between one of the others. So that's another low-res image. You can see that this controls in what order the individual C64 characters will swap between one image and the next. And how do we control how it's faded from one to the other? Why, there we will go into viewport display, the colour of the object. And we'll notice that red is controlling how it fades between one and the next. So I can keyframe the red channel and control which image is displayed. And meanwhile, green is controlling what colour selection I've got. So I put in a load of individual palettes, each using the C64's palettes, which I believe is one of these images. Which one is it called? C64 4-colour palettes. So we've got a whole selection of those, The Commodore 64, if you were in multicolour mode, you were able to display some characters as high res, so 8x8 pixels, and some characters as multicolour, which are 4x8 pixels. Within those you could have 4 colours, one of which would be the background colour, which is the same all over the screen. The other 2 could be changed, but would always be the same over the entire screen, but they could instantly be changed, and that's why we have the same images, but the colours swapped at different points. Okay. We also see, so that's how the frame works. So we've got to the end of explaining how this frame is animated and controlled. Meanwhile, we've got the text. It's the same text. As I showed earlier, the colours are no longer animated on the letters. One interesting thing about the Commodore 64 is when you entered multicolour mode, for the actual colour that you used for the character, you went down from there being 16 options to there being only 8 options. So while you're able to get 2 colours in the shading on the multicolour characters, you were only able to get 8 colours for the characters. So I wasn't able to get quite so many different blues to do that shading effect. So the text is just white now. And an interesting thing is if we look at here and we look at the modifiers, we see that we've got like lots of different geometry nodes. Each are right and erased text, and each of which has a frame start and a frame end. Let's have a quick look at the geometry nodes to see why that's possible. So we've basically, as long as the timings of these don't actually overlap, we can have as many of these as we want. And we've got this, that's controlled by this rather simple, is the text there, the frame start and the frame end. We've got lesser or equal to, and it will switch it between being, you know, all the geometry that creates the text or the original object. And the original object, it's an object with no geometry in. And that's how that works. And then we also see another instance of the bats coming in at about the same time the baseline does. It's basically doing exactly the same as the bats did earlier. It's another instance of that. And that's how that bit works. And it carries on until after a while, everything kind of breaks. This is basically, whoops, see there's a whole load of, why am I not seeing that? Let's go to the dope sheet for that. No, let's put that on. Don't know why it's not appearing in the timeline, to be honest, but let's not worry about it. You may see that the picture frame objects suddenly have shed loads of keyframes. So basically, I recorded the mouse movement out of these going wiggle, wiggle, wiggle all over the place. First with the bottom left one, then with the top right one. And that's why sometimes it glitches out going upwards. And of course, the keyframe of the red and green colour are basically fading at random. So basically, I'm glitching out the geonodes that I created earlier for this glitchy section at the end, which goes with the slightly glitchy way the music goes. The other thing is these characters being writ on the background, and that is a particle system. A simple particle system creating particles with a lifetime, with all the, where are they? It's not physics, is it? Field weights. All the gravity field weight turned off. None of the rest are actually doing anything. So they're not moving. They're just plonked down. 200 are plonked down over this time scale. And just interestingly enough, you may notice that this frame also has a collision. So when they do collide, it actually kills the particles. Because if these were being drawn and this was being drawn at the same time, if this was being drawn over that, it would delete it. You also might note, let's go to this for that. These have been stretched downward and the particles are underneath this. So when it's to collide with the particles, we need these walls here destroying them. And that, I think, concludes how this is made. Thank you very much.